Okay, I'm going to start. Is that okay with everyone?
Yep, I can hear you now.
Okay, perfect.
That's good for me.
If somebody can't hear me, please type in the window and let us know. Okay, I'm going to start. So today we do module 4, which is going to be about replication topology, the KCC process, the ISTG process, and this is going to be first part of 2. First one is we're going to go through all the what happened behind the scene, and then we're going to go next time on replication troubleshooting and see details about the up-to-dateness vector and high watermark. So let's start. Why can't I see my own screen? There we go. So AD implements a replication topology that takes advantage of the network speeds within the sites, which are ideally configured to be equivalent to LAN connectivity. And a LAN connectivity is of 10 megabits per second or higher. The replication topology also minimizes the use of potentially slow or expansive WAN links between sites. So when you create a site object in AD, you associate one or more internet protocol, actually subnets within the site. Each domain controller in a forest is associated with an AD site. A client workstation is associated with a site according to its IP address. So that means each IP address maps to one subnet, which in turn maps to one site. So AD uses sites to exactly what I've written on this slide, which is to optimize replication for speed and bandwidth consumption, helping to locate the closest DC for client logon services and directory searches. Direct the distributed file system DFS client to a server that is hosting the requested data within the site, and also to replicate sysvol, which is a collection of folders. You have group policies and logon script and so on. Okay, it was not for me. So the ideal environment for replication topology generation is a forest that has a forest functional level of at least 2003. In this case, replication topology generation is faster and can accommodate more sites and more domains than occurs when the forest has a forest functional level of Windows 2000. Hopefully none of you have Windows 2000, and the big change was in Windows 2003, and after that not much has happened. So when at least one DC in each site is running 2003, more domain controllers in each site can be used to replicate changes between the sites than when all domain controllers are Windows 2000. So the replication topology generation requires the conditions that you have a DNS, preferably DNS, AD integrated DNS. All the physical locations are represented as site objects, and they have a LAN connectivity, and IP connectivity is available between each site and all sites in the same forest that host operation master roles. So the FISMA roles must always be available. There are certain designs where you actually hide the FISMA roles, which means you need to use avoid PDC on WAN and all other goodies that I talked about in the earlier sessions. So the KCC architecture and process. So the replication topology is generated by the KCC, which is knowledge consistency checker. which is a replication component that runs as an application actually on every DC and communicates through the distributed AD database. The KCC functions locally by reading, creating, and deleting AD data. Specifically, the KCC reads configuration data and reads and writes connection objects. The KCC also writes local non-replicated attribute values that indicate the replication partners from which to request replication. For most of its operation, the KCC that runs on one domain controller does not communicate directly with the KCC on any other domain controller. Rather, all KCCs use the knowledge of the common global data that is stored in the configuration directory partition as an input to the topology generation algorithm to converge on the same view of the replication topology. So each KCC uses its in-memory view of the topology to create inbound connections locally, manifesting only those results that apply to itself. So the KCC communicates with other KCCs only to make a RPC request for replication error information. The KCC uses the error information to identify gaps in the replication topology. A request for replication error information occurs only between DCs in the same site, not out of site. And in some white papers, there are statements that are untrue, so I'm just going to kill them right here and now. And that is the KCC uses only RPC to communicate with the directory service. KCC do not use LDAP. No matter who wrote it, it's not true. KCC do not use LDAP. One domain controller in each site is selected as the intersite topology generator, which is called ISTG. This is to enable replication across site links. The ISTG automatically designates one or more servers to perform site-to-site replication. And those servers are called bridgehead servers. A bridgehead is a point where a connection leaves or enters a site. So the ISTG creates a view of the replication topology for all sites, including existing connection objects between all DCs that are acting as bridgehead servers. The ISTG then creates inbound connection objects for servers in its site that it determines will act as bridgehead servers and for which connection objects do not already exist. So the scope of operation for the KCC is the local server only, and the scope of operation for the ISTG is a single site. Each KCC has the following global knowledge about objects in the forest, which it gets by reading objects in the sites container of the configuration directory partition, and which it used to generate a view of the replication topology. So the knowledge it has is sites, servers, site affiliation of each server, global catalog servers, directory partitions stored by each server, site links, and site link bridges. So as you see, the following the picture here shows the KCC architecture on servers in the same forest in two sites. Individual KCCs create connection objects on behalf of the local DC. The KCCs use global data in AD to create only the connection objects that apply to the local server or site, and for the site it's the ISTG. Together, this process creates the replication topology for each site and between sites. So we have the KCC to KCC communication for errors. We have the ISTG generates connection objects on behalf of its local site. And the KCC communicates with the subsystem within the DSA, which reads data to the database. So we have the KCC, which is running on each DC, communicates directly with the ntdsa.dll that we talked about in the first session. And it uses that to read and write replication objects. The DSA, the directory system agent. So the directory service component that runs as ntdsa.dll on every domain controller provide the interfaces through which services and processes, such as the KCC, can gain access to the directory database. The ESE, Extensible Storage Engine, the directory service component that run as esent.dll. ESE manages the table of records, each with one or more columns. The table of records comprise the directory database. RPC So the direct replication service, which is called DRSUAPI, RPC protocol, used to communicate replication status and topology to a domain controller. The KCC also uses this protocol to communicate with other KCCs to request error information when it's building the replication topology. And lastly, the ISTG. It's the single KCC in a site that manages inter-site connection objects for the site as a whole. So as you can see, the four servers in the picture create identical views of the servers in their site and generate connection objects on the basis of the current state of AD data in the config partition. In addition to this, to creating its view of the servers in its respective site, the KCC that operates as the ISTG in each site also creates a view of all servers in all sites in the forest. From this view, the ISTG determines the connections to create on the bridgehead servers in its own site. What you also need to know that a connection requires two endpoints, one for the destination DC and one for the source DC. And the DCs created an intra-site topology always use themselves as the destination endpoint and must consider only the endpoint for the source DCs. The ISTG, however, must identify both endpoints in order to create connection objects between two other servers. So let's look at the KCC and ISTG views. So the KCC creates two types of topologies, intra-site and inter-site. Within a site, the KCC creates a ring topology by using all servers in the site. To create the inter-site topology, the ISTG in each site uses a view of all the bridgehead servers in all sites in the whole forest. So the picture shows a high-level generalization of the view that the KCC sees of an intra-site ring topology and the view that the ISTG sees on the inter-site topology. So the lines between domain controllers within a site represent inbound and outbound connections between the servers. The lines between sites represent configured site links. And the bridgehead servers are represented as BH, as you can see over here. So the KCC and the KCC with the ISTG has a completely different view of AD, and it has absolutely nothing to do with the actual network. So the AD replication topology can use many different components. Some components are required, and others are not required but are available for optimization. The picture illustrates most of the replication topology components and their place in an example AD multi-site and multi-domain forest. The depiction of the inter-site topology that uses multiple bridgehead servers for each domain assumes that at least one domain controller in each site is running 2003, as I said earlier. So in the picture, all the servers are DCs. They independently use the global knowledge of configuration data to generate one-way inbound connection objects. The KCCs in a site collectively create an intra-site topology for all DCs in the site. The ISTGs from all sites collectively create an inter-site topology. So within sites, one-way arrows indicate the inbound connections by which each DC replicates changes from its partner in the ring. For inter-site replication, one-way arrows represent inbound connections that are created by the ISTG of each site from bridgehead servers. For the same domain in other sites that share a site link, of course, or from a global catalog server acting as a bridgehead if the domain is not present in the site. And you can see the domains are indicated by D1, D2, D3, and D4. Each site in the diagram represents a physical LAN in the network, and each LAN is represented as a site object in AD, and the red solid lines between sites indicate WAN links over which two-way replication can occur, and each WAN link is represented in AD as a site link object. Site linked objects allow connections to be created between bridgehead servers in each site that is connected by the site link. What is not shown in this picture is that where WAN links are available, replication between sites uses the RPC replication transport. RPC is always used within sites. The site link between site A and D, which is site A and site D, uses SMTP protocol for the replication transport to replicate the configuration and schema directory partitions and global catalog partial read-only directory partitions. You know that although the SMTP transport cannot be used to replicate writable domain directory partitions, this transport is required because of TCP/IP connection is not available between site A and site D. So this configuration is acceptable for replication because site D does not host a DC for any domains that must be replicated over the site link AD. So you see, we only have domains D1 and D2. We don't have domains D1 and D2 here, therefore it's okay to replicate over SMTP. So by default, site links AB and AC are transitive, which is, depending on the white paper and who wrote it, it's also called bridged, which means that replication of domain D2 is possible between site B and site C. Although no site link connects to two sites, the cost values on site links AB and AC are site link settings that determine the routing preferences for replication. This is based on the aggregated cost of available site links, and the cost of a direct connection between site C and site B is the sum of the cost on site links AB and AC. So that means replication between site B and site C is automatically routed through site A to avoid the more expansive transitive route, and connections are created between site B and site C only if replication through site A becomes impossible, and impossible meaning the network goes down or the bridgehead server is dead. So what are the goals for this? Well, the KCC generates a replication topology that achieves the following goals, and the goals are: connect every directory partition replica that must be replicated, control replication latency and cost, route replication between sites, and affect client affinity. So by default, the replication topology is managed automatically and optimizes existing connections. However, manual connections created by an admin are not modified or optimized. So if you can avoid it, don't create manual links. So let's go through a little deeper what it also means. So the total replication topology is actually composed of several underlying topologies, one for each directory partition. In the case of the schema and configuration directory partitions, a single topology is created. The underlying topologies are merged to form the minimum number of connections that are required to replicate each directory partition between all DCs that store replicas. So where the connections for directory partitions are identical between domain controllers, let's say, for example, two DCs store the same domain directory partition, a single connection can be used for replication of updates to the domain, schema, and configuration directory partitions. A separate replication topology is also created for application directory partitions. However, in the same manner as schema and configuration directory partitions, application directory partitions can use the same topology as domain directory partitions. So when application and domain directory partitions are common to the source and destination DCs, the KCC do not create a separate connection for the application directory partition. So a separate topology is not created for the partial replicas that are stored on global catalog servers. The connections that are needed by a global catalog server to replicate each partial replica of a domain are part of the topology that is created for each domain. The routes for the following directory partition or combinations of directory partitions are aggregated to arrive at the overall topology, which is configuration and schema within site, each writable domain directory partition within a site, each application directory partition within a site, global catalog read-only partial domain directory partitions within a site, configuration and schema between sites, each writable domain directory partition between sites, each application directory partition between sites, global catalog read-only partial domain directory partitions between sites. So that is how it actually put it all together. So the replication transport protocols determines the manner in which replication data is transferred over the network media. So your network environment and server configuration will dictate the transports you can use. Control replication latency and cost. So replication latency is inherent on a multi-master directory service. A period of replication latency begins when a directory update occurs on an originating domain controller and ends when replication of the change is received on the last domain controller in the forest that requires the actual change. So generally, the latency that is inherent in a WAN link is relative to a combination of the speed of the connection and the available bandwidth. Replication cost is an admin value that can be used to indicate the latency that is associated with different replication routes between sites. A lower cost route is preferred by the ISTG when generating the replication topology, and site topology is the topology as represented by the physical network, the LANs, WANs that connects your DCs in the forest. The replication topology is built to use the site link topology. The site topology is represented in AD by site objects and site linked objects. So these objects influence AD replication to achieve the best balance between replication speed and cost of bandwidth utilization by distinguishing between replication that occurs within a site and replication that must span sites. So when the KCC creates replication connections between DCs to generate the replication topology, it actually creates more connections between DCs in the same site than between DCs in different sites. So this results in the results actually are lower replication latency within a site and less replication bandwidth utilization between sites. So within sites, replication is optimized for speed, as the slide says. Connections between DCs are always arranged in a ring. Replication within a site is triggered by change notification, and data is sent uncompressed. So what about between sites? So between sites, we have another goal, and that is we need to optimize it for minimal bandwidth usage, which is basically cost. So between site, we actually compress data to minimize the bandwidth. We do a store and forward replication, which makes efficient use of WAN links. We also can set a schedule when we want the replication to occur, so we can say only after 10 o'clock at night or whatever. And the intersite topology is a layering of spanning trees, which means one intersite connection between any two sites for each directory partition, and it generally does not contain redundant connections. So the route replication between sites is actually, it happens like this. The KCC uses the information in AD to identify the least cost routes for replication between sites. If a DC is unavailable at the time the replication topology is created, making replication through that site impossible, the algorithm will go to the next least cost route instead and use that. And this rerouting is automatic when site links are bridged or transitive, depending. It means the same thing, which is also the default setting. So it's always best to let KCC and ISTG do the work. And replication is automatically routed around network failures, such as offline domain controllers, or when it can't reach the destination in some way. Route replication between sites. Excuse me. The KCC uses the information AD to identify the least cost routes for replication between sites. If a domain controller is unavailable at the time, as I told you, when the replication is created, making it impossible, as I said, the next least cost route is used. And you need to do this, you need to let KCC and ISTG create this for you. If you do it manually, you will not be able to have this automatically rerouting. So, how it affects client affinity. AD clients locate domain controllers according to their site affiliation. DCs register SRV resource record in the DNS database. These records map the domain controllers to a site. So when a client requests a connection to a DC, let's say for example logging onto a domain computer, the DC locator uses the site SRV resource record to locate a DC with good connectivity whenever possible. In this way, it means that the domain controller within the same site, and thereby avoiding communications over WAN links. And now the big question. Do you remember what I told you about mnemonics last time? Let's see if I have some questions. No questions. This is the idea behind it all. So the DC locator tries to connect the client to the closest domain controller within the site, and I said last time and that is not always happening, and that's still true. My statement is still true. So if you add DNS mnemonics, you actually control which SRV resource records should be published where. So let's say, for example, I log on here in Uppsala in Sweden, and I'm sitting next to my domain controller. But if I don't have mnemonics, and the actual client will take the first on the list of DCs it gets, and it can get a list of a DC in Singapore. I don't want to have my logon traffic routed through Singapore then back when I have a DC very close to me. So what I do with mnemonics is I saying, don't publish your resource record outside of your own site. And then I say, if I don't have a DC within my site, I go to the hub site instead. That's how mnemonics basically works. Sites can also be used for certain applications such as DFS to ensure that clients locate servers that are within the site, or if there's none available, a server in the next closest site. If the ISTG is running on 2003 or later, you can specify an alternate site based on connection cost if no same site servers are available. This DFS feature is called site costing, and you have to do it through the command prompt. At least last time I did. So let's look at the topology related objects in AD. So AD stores replication topology information in the configuration directory partition. Several configuration objects define the components that are required by the KCC to establish and implement the replication topology. So what we use is AD sites and services to view and manage this hierarchy of objects that are used by the KCC to construct the replication topology. The hierarchy is displayed as the contents of the sites container, which is a child object of the configuration container. As you can see, the config container is not identified in Sites and Services UI. The sites container contains an object for each site in the forest. In addition, sites contains the subnets container, which contains subnet definition in the form of subnet objects. The picture shows an example from one of my test domains. So I have two sites, default first site name and Uppsala. The selected entity settings object of the server POC DC1 in the site default first site name displays inbound connection from POC DC2 from the site Uppsala. So this shows me that POC DC1 and POC DC2 perform inter-site replication. And let me walk you through the objects. So site and subnet objects. Sites are effective because they map to specific ranges of subnet addresses. As identified in AD by subnet objects, the relationship between sites and subnets is key to AD replication. So if we look at the site object itself, a site of class site corresponds to a set of one or more IP subnets that have LAN connectivity. So by virtue of their subnet associations, DCs that are in the same sites are well connected in terms of speed. Each site object has a child entity as site settings object and the server's container. And this distinguished name of the sites container is cn equals sites, cn equals configuration, dc equal your forest root domain name. So the configuration container is the topmost object in the configuration directory partition, and the sites container is the topmost object of objects that are used to manage and implement AD replication. So when you install AD on the first domain controller in the forest, a site object is named default first site name. It's created in the sites container in AD. And I strongly encourage you to rename default first site name to something meaningful to you. Usually the default first site name, that site is usually a hub site or something like that. Subnet objects, which is the class subnet. It defines the network subnets in AD. A network subnet is a segment of a TCP/IP network to which a set of logical IP addresses is assigned. Subnet group computers in a way that identifies their physical proximity on the network. So subnet objects in AD are used to map computers to sites. Each subnet object has a site object attribute that links it to a site object. So the attribute that actually tells you where it belongs to is the site object. Subnet to site mapping. So you associate a set of IP subnets with a site if they have high bandwidth, which means LAN connectivity. And by that, it's okay to have your LAN connectivity involving hops through high-performance routers. That's absolutely no problem. And as I said, LAN connectivity assumes high-speed, inexpensive bandwidth that allows similar and reliable network performance, regardless of which two computers in the same sites are communicating. So this quality of connectivity does not indicate that all servers in the site must be on the same network segment or that hop counts between all servers must be identical. But rather you should see it as it's a measure by which you know that if a large amount of data needs to be copied from one server to another, it does not matter which servers are involved. If you find that you have concern about a situation like that, you really need to consider creating another site instead. When you create subnet objects in AD, you associate them with site objects so that IP addresses can be localized according to sites. During the process of a DC location, subnet information is used to find a DC in the same site as or the site closest to the client computer. The NetLogon service on a domain controller is able to identify the site of a client by mapping the client's IP address to a subnet object in AD. Likewise, when a DC is installed, its server object is created in the site that contains the subnet and maps to its IP address. So you can use AD sites and services to define subnets and then create a site and associate the subnets with the site. By default, you have to know that only enterprise admins have the right to create new sites. You can, of course, delegate this. And in a default AD installation, there is no default subnet object. So potentially a computer can be in the forest but have an IP subnet that is not contained in any sites. So what will happen with a client that has an IP which is not connected to any subnet that is defined in sites and services? Basically, that client will say, hey, Mr. DNS, give me a list of all your domain controllers and I will use the first one I get. So you can have a client logging on in Uppsala and it will utilize a domain controller in, I don't know, Australia, for example. What I usually do, I usually create something I call a catch-all subnet. So let's say I have my subnet here in my test LAN is 192.168.0, and then I have another one that is 192.168.2, and so on and so forth. And then I have a client that is 192.0.0.10. That client will only totally scream and say, hey, I don't belong anywhere, give me something. So what I do is I always do a catch-all subnet. So I define in the 192 case, a C address, I define 192.0.0.0/free because that covers all the Class C addresses. And when the evaluation of a client's IP is done, it will get to the closest one they can get. So a catch-all is only there for catching subnets I missed to actually registered. So I make sure if I miss something, use these servers. That's what I'm basically saying. But if you have an IP that's matching closer to my 192.168.1 subnet, then I can use that instead. They will actually use that instead. So a catch-all subnet is something you really should think about. It's a good thing. So let's talk about the server object. So the server object, which is of course class server, represents server computers, including domain controllers, and they are located in the configuration directory partition. So when you install AD, the installation process creates a server object in the service container within the site to which the IP address of the DC maps. There is one server object for each domain controller in the site. A server object, this is very important, a server object is different from the computer object that represents the computer as a security principal. These objects are in separate directory partitions and have separate GUIDs. The computer object represents the domain controller in the domain directory partition. The server object represents the domain controller in the configuration directory partition. And the server object contains a reference to the associated computer object. So the server object for the first DC in the forest is created in the default first site name. And when you install AD on a subsequent servers, if no other sites are defined, server objects are created in default first site name. If other sites have been defined and subnet objects have been associated with these sites, server objects are created as following. If additional sites have been defined in AD and the IP address of the installation computer matches an existing subnet in a defined site, the DC is added to that site. If additional sites have been defined in AD and the new domain controller's IP address does not match an existing subnet in one of the defined sites, the new domain controller's server object is created in the site of the source domain controller from which the new domain controller receives its initial replication. So when AD is removed from a server, its NTDS settings object is deleted from AD, but its server object remains sometimes because the server object might contain objects other than NTDS settings. For example, operations manager or message queuing, which is running on a DC, because these applications create child objects beneath the server object. So even if you know this DC is not longer in use, don't just go and delete the NTDS settings object before you actually make sure no other object is actually utilizing it. The NTDS settings object, which is of class NTDS DSA, represents an instantiation of AD on that server and distinguishes a DC from other types of servers in the site or from decommissioned DCs. For a specific server object, the NTDS settings object contains the individual connection objects that represent the inbound connection from other DCs in the forest that are currently available to send changes to this domain controller. So, and again, I would just strongly need to say that NTDS settings object should not be manually deleted unless you are 100% sure on what you are doing. The HasMaster NC's multi-valued attribute, and NC stands for naming context, which is just a synonym for directory partition. So the multi-value attribute of an NTDS settings object contains the distinguished name for a set of writable non-global catalog directory partitions that are located on that domain controller. And the three that is actually has is the configuration, the schema, and the domain partition. The MSDS HasMaster NC's attribute is new from 2003. And this attribute of the NTDS settings object contains values for the above named directory partitions, as well as any application directory partition that are stored by the DC. Therefore, domain controller that also is a DNS server and use AD integrated DNS zones, you actually have two more partitions called forest DNS zones and domain DNS zones. So applications that need to retrieve the list of all directory partitions that are hosted by a DC can be updated or written to use the MSDS hasmaster NCs attribute. And applications that need to retrieve only DC partitions can continue to use the hasmaster NCs attribute. So if you're into dev, you have two attributes that you can play along with. Let's see if there was any. Good point, Lasse. Exchanges. Well, I'm not going to say anything. Connection objects. Connection object class NTDS connection defines a one-way inbound route from one domain controller, which is the source, to the domain controller that stores the connection object, which is the destination. The KCC uses information in cross-reference objects to create the appropriate connection objects, which enable DCs that store the same directory partitions to replicate with each other. The KCC creates connections for every server object in the site container that has an NTDS settings object. The connection object is a child or replication destination's NTDS settings object, and the connection object references the replication source DC in the from server attribute on the connection object. So that is, let's say, it represents the inbound half of a connection. The connection object contains a replication schedule and specifies the replication transport. The connection schedule is derived from the site link schedule for inter-site connections. And the connection is unidirectional. A bidirectional replication connection is represented as two inbound connection objects. So I say it again, a connection is unidirectional. And when you hear bidirectional replication connection, it's actually two inbound connection objects. So the KCC creates one connection object under the NTDS settings object of each server that is used as an endpoint for the connection. And the connection objects can be created in two ways, automatically by the KCC or manually by the admin, or you can do ADS-edit or scripts or LDP or whatever tool you want. And the KCC from 2003 is competent enough that I seldom see the need to manually create site connection objects. Inter-site connection objects are created by the KCC that has the role of ICG in the site. One DC in each site has this role, and the ICG role owners in all sites use the same algorithm to collectively generate the inter-site replication topology. The ownership of connection objects. Connections that are created automatically by the KCC are owned by the KCC. If you create a new connection manually, the connection is not owned by the KCC. So that means if a connection is not owned by the KCC do not modify it or delete it. You as an admin have to take care of it yourself. There's one exception to this modification rule, is that the KCC automatically changes the transport type of an admin-owned connection if the transport type attribute is set incorrectly. However, if you modify a connection object that is owned by the KCC, let's say you, for example, change the schedule, the ownership of the connection depends on the application that you use to make the change. Why make it easy? So if you use an LDAP editor such as LDP or ADS-edit to change the connection object property, the KCC reverses the change the next time it runs. If you use sites and services to change the connection object property, the object is changed from automatic to manual and the KCC no longer owns it. So the UI indicates the ownership status of each connection object. In most AD deployments, manual connection objects are not needed, as I said before. So if you create the connection object, it remains until you delete it. But the KCC will automatically delete duplicate KCC owned objects. if they exist and will continue to create needed connections. Ownership of a connection object does not affect security access to the object. It determines only whether the KCC can modify or delete the object. It has nothing to do with ACLs and stuff like that. So you have to understand that if you create a new connection object that duplicates one that KCC has already created, your duplicate object is created and the KCC created object is deleted by the KCC the next time it runs. Let me get some water. ISTG and modified connections. Because connection objects are stored in the config directory partition, it is possible for an inter-site connection object to be modified by an administrator on one domain controller and prior to replication of the initial change being received to be modified by the KCC on another domain controller. Overwriting such a change can occur within the local site or when a connection object changes in a remote site. By default, the KCC runs every 15 minutes. So if the administrative connection object change is not received by the destination DC before the ISTG in the destination site runs, the ISTG in the destination site might modify the same connection object. In that case, the ownership of the connection object belongs to the KCC because the latest write to the connection object is the write that gets applied. Manual connection object. KCC is designed to produce a replication topology that provides low replication latency, that adapts to failures, and that does not need modification. It is usually not necessary to create a connection object when the KCC is being used to generate automatic connections. The KCC automatically reconfigures connections as conditions change. Adding manual connections when the KCC is employed potentially increases replication traffic by adding redundant connection. When manually generated connection exists, the KCC use them whenever possible. So adding extra connections does not necessarily reduce replication latency. You have to remember that. Within a site, latency issues are usually related to factors other than the actual replication topology, which is generated by the KCC. Factors that affect latency include some of the following: interruption of the service of domain controllers, such as the PDC emulator, global catalog servers, or bridgehead servers. DCs are too busy to replicate in a timely manner, which often is a result of you have too few domain controllers. Network connectivity issues, DNS server problems, and inordinate amounts of directory updates, which means you update your AD too much and it can't replicate all the changes. So if you have problems like this, creating a manual connection to improve replication latency, adjusting the scheduling and cost that are assigned to the site link is the best way to influence inter-site topology. Let's see if Site links objects. For a connection object to be created on a destination DC in one site that specifies a source DC in another site, you must manually create a site linked object. The site linked object connects the two sites, and site linked objects identify the transport protocol and scheduling required to replicate between two or more sites. You can use AD sites and services to create site links. The KCC uses the information stored in the properties of these site links to create the inter-site topology connections. A site link is associated with a network transport by creating the site linked object in the appropriate transport container, which is either IP or SMTP. All inter-site domain replication must use IP site links. The SMTP transport can be used for replication between sites that contain domain controllers that do not host any common domain directory partition. Site link properties. A site link specifies the following, which is two or more sites that are permitted to replicate with each other. A defined cost value associated with that replication path. And this cost value controls the route that replication takes, and thus the remote sites that are used as sources of replication information. It also specifies a schedule during which replication is permitted to occur. It also specifies an interval that determines how frequently replication occurs over this site link during the times when the schedule allows replication. When you install AD on the first domain controller in the forest, an object named default IP site link is created in the sites container. It's in the IP container within the inter-site transport container. So it's going to be in here. And this link contains only one site, default first site name. But when it comes to site link bridging, by default, site links for the same IP transport that have sites in common are bridged, which enables the KCC to treat a set of associated site links as a single route. If you categorically do not want KCC to consider some routes, or if your network is not fully routed, you can disable automatic bridging of all site links. When this bridging is disabled, you can create site link bridge objects and manually add sites to links to a bridge, or add site links to a bridge, sorry. The NTDS site settings object, which is NTDS site settings, identify site-wide settings in AD. There is one NTDS site settings object per site in the sites container. NTDS site settings attributes control the following conditions and features. It identifies the ISTG role owner for the site. The KCC on this DC is responsible identifying bridgehead service. It also controls whether domain controls in the site cache membership of universal groups, and the site in which to find a global catalog server for creating the cache. It also contains the default schedule that applies to connection objects. Crossref objects store the location of directory partitions in the partitions container, which is CN partition, CN configuration, DC forest root domain name. The contents of the partitions container are not visible by using the sites and services snap-in, but you can view it through ADSI edit, and if you want to. AD replication uses cross-reference objects to locate DCs that store each directory partition. A crossref object is created during AD installation to identify each new directory partition that is added to the forest. Crossref objects store the identity, which NC name, also the distinguished name of the directory partition, where NC stands for naming context, of course. And it also stores the location of each directory partition. And if you're not already on Windows 2003, there was a new special attribute for the crossref object was created, and it's called MSDS NC replica location. And it's actually used for identifying application partitions, application directory partitions to the replication system. And I think I'm done for the day. And I will absolutely tell you what I'm going to talk about next time. Next time I'm going to talk about more on replication. We're going to troubleshoot some replication. We're going to talk about high watermark, up-to-dateness vector. I'm going to show you some cool new tools, and to help you to discover replication issues and how to solve them. A lot of stuff with RepAdmin will be done next time as well, and also some PowerShell with RepAdmin. So thank you for today.
Great stuff, Yumi. Can you hear me?
Yes, and we got a great question from Kenneth as well. When is the next time?
Yeah. Do you know? Well, next time is...
I think it's the 14th, right?
Yeah, that's what I think as well. Mm-hmm.
Yeah, because we're going to Microsoft, all of us.
No.
Aren't you going to the summit as well? And that's why we...
Oh, yeah, of course. That's why we do it the 14th, and it's a regular Linkcast.
Yep.
Yeah. We will update Yammer and stuff. Well, I thank you for your enthusiasm, Jimmy. It's crazy stuff. And we will take a 30-minute break, and then we will continue with Link. Not Exchange, but Link, and then Exchange will be on 11:30 or 12. 12 it is. And I'm going to talk about backup.
Cool stuff.
Yep.
See you in half an hour. Bye-bye.
Half an hour. Bye-bye.